Life is a journey full of challenges, and sometimes it can be a challenge to make the right decision. Hi, this is Sundar Raj from Francis Xavier Engineering College, Department of Information Technology of 2020 batch. This 4 years of engineering journey taught me many lessons. This is the platform where I found myself. My department faculty guided me in the right way to choose my domain. On my second year of engineering, I got IBM certified on predictive modeling, which helped me to choose my domain as a data scientist. And of course, I have done many projects on data science, which is related to the real-time projects and helped me in a way to get placed in my major. Of course, college means degree and degree means job. Thanks to Francis Xavier Engineering College for providing me a best training regarding the placements, which helped me to get placed in car technologies with the annual CTC of 5 lakhs and also in Cognizant with the annual CTC of 4 lakhs. Being in Francis Xavier Engineering College is like staying on the road to the Damascus, where you can gain the required knowledge to achieve your goals. Thank you.
Hello participants, happy morning to all. This is Dr.A.Anitha, Professor from Francis Xavier Engineering College. It's my great pleasure to welcome you all for this webinar on data handling with R. Before getting to webinar, I like to thank our management, General Manager Development, Principal and HOD for giving me this opportunity to host a webinar in my area of specialization. The goal of data science is to convert data into information and information into insight. So how can we convert the data into information? Through data manipulation only this is possible. In this session, we are going to learn about various data manipulation operations available in R and how to get the deep insight into the data. Yes, it's possible to have the data without any information, but it's no way possible to get the information without any data. Let us start this session now. So let me start the presentation now. Data handling R. In this session, we are going to discuss about why we go for R versus Python, installation procedure with R, then mathematical operations to be carried out in R, then basic programming features like variables, data types, control structures and functions, and some data handling operations like sequences, vectors, mathematical library functions, matrices and so on. So let us first see what is R and why we go for R. R is an open source statistical programming language. Like any other programming language, we can do programming with R. Many people are getting confused with whether R is a tool or programming language. This is a programming language that is developed specifically for statistical operations and data science operations. Why its naming convention is like R means this name came from the scientists who developed this language, Rose Ihaka and Robert Gentleman. Their first letters gave the name to R. R is used for analytical modeling and machine learning operations. Then R versus Python. How this R and Python are in their features. Let us see. First of all, R is a special language for data analytics. If you know data science operations well and machine learning operations well, means it's better you can go for R. Moreover, there are some statistical packages like MATLAB and SPSS. If you know all these statistical operations, R is well and good. However, Python is a general purpose programming language. If you want to code from the scratch, you can go for Python. The special feature is we use R mainly for business analytics. For business decision making purpose, R is used. And if you want to integrate data science operations in web-related applications, you can go for Python. Both are open source languages only. Then application includes enterprise application. It's used for enterprise application, whereas Python is used for household codes. Then flexibility with the data handling is here. R supports some kind of special packages like Tidivers, ggplot, Caret, Zoo, and Python has some specific libraries: Pandas, SciPy, Scikit, TensorFlow, and Caret. And major uses of R are Twitter. Python is used in Google, Netflix, Dropbox, Instagram, and all. However, it's the choice by the programmers. If we know the statistical operations and if you know the data science operations very well, means you can go for R. So, for scientific programming languages, Math uses some statistical operations which are more similar to R. In Python, we do scratch coding. Then IDE related with R is RStudio. For Python, we use Spider and Jupyter Notebook. Next is installation procedure with R. To install R, we need two major procedures. One is installation of R console and then installation of RStudio. R console is used for carrying out command line operations in R, and RStudio provides IDE, integrated environment. Okay, let us see how to install R console first. Both are open source, so you can straight away start with searching R console. I'll show you. Here you can give download R for Windows. Because I already installed various latest libraries and packages with R, I can't fully demonstrate this installation procedure. I'll show you how to start and then followed by some screenshots. So if you give download R for Windows, you will get some major links: R for Windows with CRAN and download R 4.0.2. So this is the latest version. R versions are released around every 3 to 6 months. So 4.0.2 is the latest version in R. You can click that. In that, you will be getting links for Windows and other OS. In that, select download R 4.0.2 for Windows. This will be supported by 32-bit and 64-bit operating systems. So we can choose this. It will ask where to store. So you may give, let me choose some folder. It will start installing. Because it will take some time, I will show you to the next step. So we have seen this step. After the completion of installation, you will be getting this one: open i386 4.0.1. You can see it here. You will be getting one folder for R console. See here, this is folder for R console. Here, select i386 4.0.1. You will be getting this window. This is our console window. This is like a command line operations. You can carry out execution of R statements one by one. For example, let me write the first R code: print welcome participants. So let me execute. To execute this, you can press Ctrl R. So this is the output. Welcome participants is a string, so it's displayed in double quotes. I can also give the same string in double quotes. It will also work. Welcome to our class. Problem with R console is it's possible for you to do line by line execution, as well as it's difficult to do debug. So we go for IDE. Let me close this console window. I have not saved that. So this is what we got. This screen I have shown you now. The next one is installation of RStudio. Let us see how to install RStudio. RStudio free download. Here you can click download RStudio. After installing R console only you have to install RStudio, because installation of R console will set up the environment for that. After that you have to install RStudio. Here you will get this screen. Here several versions are available. In that there are two versions. RStudio Desktop and RStudio Server are available as free. If you want to use in network, you can go for RStudio Server. For standalone systems, we can use RStudio Desktop. So let me click download here. Here is the installation steps. Install R and then download RStudio Desktop. We finished installation of R. So let me proceed with second step, download RStudio Desktop. Here the exe files are given for different versions of operating systems. In that we can choose Windows 10 or 8 or 7. RStudio 1.3.959 exe. Even though R provides different versions, there won't be much difference between various versions. If you know the basic syntax related, you will be able to work with any version of R. Okay, so let me store in D drive. So here installation started. It will take some time as I already installed. Let me cancel this installation and show you the next screen. We have seen up to this step. So next step is, I have stopped with this step, right? So next step is RStudio setup wizard. You can give next for that. Next, it starts installing. Then it will ask for shortcut where to give. Here you can give start menu program files like as you wish. Then install, then finish. So with this completing RStudio setup wizard. After finishing that, you will be getting this kind of blue color circle. Are you able to see? So this is RStudio shortcut. You can click RStudio. So this is RStudio IDE. It has 4 major windows. First first one is this window is here. This window is called script window. Here you can write your R programs. Then this window is console window. Here you can see the stepwise output. And this is called environment window. Here we can see the variables and their corresponding values for after every step of evaluation. And this is called files window. Here we will be able to see the current working directory, what are the files stored in the current working directory. And this plots menu is used to see the graphs. If you write code for any visualization techniques, you'll be able to see the graphs in this window. Then packages. R supports various packages with different built-in library functions. You can install as based on your application. Then this help window, you can find any topic here. And if you give help, you will be able to get that. Then viewer window is for viewing your operations. Right. Now, let me set the current working directory before getting to R scripting. D drive. I am choosing D drive as my current working directory. In that you can you can create some folder. I can use R sample, or I can create some new folder in D drive, R code. So D drive R code is my current working directory. D drive R code. Here nothing is available. So let me write the scripts one by one and store in this folder. To make it current working directory, go to more and set as working directory. Okay, fine. Now let us start with first program. Print my first program. Let me execute this one. I am pressing Ctrl Enter. Here is the output. This is script window. Here you can write your code or script. And here we can see the output. Here what you are seeing in blue color is the actual statement or script code. And this black color line is only the output. Here in this program, I have not used any variables, so nothing is displayed in global environment. Let us see what's happening when I store this. Save as first.r. See, you can see this file here, first.r. It's a current working directory. Okay. So let us start how to work with RStudio. First is basic mathematical operations. As like any programming languages, we can do normal basic operations in subtraction, multiplication, division, exponential, modulus, and integer division. Without using variables, like simply with the integers, I'll demonstrate all the operations. I am adding 5 plus 6, then 5 minus 6, 6 by 3, 3 star 2, 3 double star 2, 3 cab 2, I'll execute all the statement at a stretch. This is addition, subtraction, division, multiplication, and this last two, 6th and 7th statement. These two are exponent. That means power. So I'll execute. Here, I don't want to execute the first sentence. So I'm selecting remaining only. Before that, I want to clear this console. So you can give Control L to clear this console. That is the shortcut. So that we might not get confused with the previous output screen. So I'm selecting only these basic arithmetic operations and executing. See the results. First statement is 5 plus 6. So output is 11. 5 minus 6 minus 1. 6 by 3 is 2. 3 into 2 is 6. See the power function 3 square. 3 double star 2 is 3 square. That is 9. Same thing can be expressed using cab operator. 3 cab 2. Okay. Now let us see what's the difference between integer and normal integer division and modulo operation. 5 mod 2. 5 mod 2 is 1. This is output of modulo. Suppose I am giving 8 mod 3. 8 slash 3. What will you get? 2.7. 2.6. This is a float value we are getting. Suppose I want to make it as an integer. How can I do? 8 percentage slash. See the difference? 8 slash 3 return the decimal part and 8 integer division 3 returns only the integer value. So this is the main difference here. And one more thing, using this power function, it's possible to you to find the square roots or cubic roots. We have found 3, 3 square as 9. Suppose I want to find root. How can I give? 3 double star 1 by 2 or 0.5. It will give root 3. 1.732. That is value of root 3. Okay, so these are the basic mathematical operations with R. So let me save this. My first R program. Next is variables. Variables are of dynamic dynamic values, changing values that we. While naming the variable, we have to start with alphabet. Variables cannot use special symbols except this underscore and dot. However, you can use both alphabets and numerals in naming the variables. There are two functions associated with variables, type of and class of. Let us see how these functions can be used and how variables can be used in R. Let me start a new file for this. For demonstrating variables, I can give the comment statement using hash variables demo. Multi-line comments is not allowed in R programming. If you want to comment multiple lines, you have to use this hash symbol repeatedly. Let me declare some variable x equal to 10. Here, in Python, here also there is no special declaration statement. Every variable will take the data type of values assigned. Now I am assigning value 10 to x. Whether x is an integer or float. how this R will consider. Let us see the output x equal to 10 and x. Okay. Here only there are two possibilities. X may be either integer or float. Let us see how it turns. I am clearing this console window using Control L. See, now we have used a variable x which has got the value 10. Okay. So this is a global environment. It will take the updated value of x. So x equal to 10, the value is printed. Same thing you can print using this statement, print of x. Same you will get. Okay. Now it seems x is getting the value of 10, like integer value. But actually this is not integer. Let us check which data type it holds. Type of x. See, this is of data type double. Because by default, the value will be considered as 10.0.0 something. Okay. Like, then let us check the use of class of function, class of x. See, this is of numeric class. What's the difference between this type of and class of? Means type of will take the data type that belong to a class numeric. In R, the numeric class contains two kinds of data, two types of data. That is, one is double and integer. Okay. Whatever integer value I am assigning to some variable will be considered as double. Then how can we create an integer variable? There are multiple ways for that. Let me use x equal to 10L. Control C and Control V. X instead of the 10, I can give 10L. After that, let us check. Now, this first block, I am giving x equal to 10 and seeing the type and class. In the second block, I am giving x equal to 10L. I am going to see the values. Let me run this. You can see the difference here. For the first block, for the it has got as before because we didn't made any change. 10 print of x, then type of x is double, its class is numeric. Change value of 10 followed by L. It will take the same value 10, but its data type is integer. Okay, so this is what the difference. Then let me use next data type 10.75. Ten point 75. This is for float values. For parity, I am clearing then and there using Control L. So 10.75. This is of double data type belonging to numeric class. This is an example for float values. Then I will demonstrate with some character variable x equal to hello. This is for character data type. You can also give in single quote. You can see the type is character, class is character. The next one is the value x equal to true. type of x, class of x. See here, it's of a logical value. X is true, its value is true. Let me check whether it's working for value t. You can see the change here. X equal to true. Initially it had the value 10, then 10.75. After that x value is changed as hello. And every update in value of variable will be reflected here. It's shown here. Yes, you can assign x with simple t. By default, it will be considered as true. For false, you can give simple capital F. So let me save this variables demo. It will be shown here, variable demo. Let us move to next topic. Keywords. R supports this type of special words or keywords: if, else, repeat, while, break, true, false, null. NA means not available. NAN, function, for, list, matrix, next. Here is a special one. NAN stands for not a number. These keywords cannot be used for naming the variables or functions, user-defined functions and all. So next one is data types. Variables we have seen already. So move to next topic, basic data types. These keywords I will explain you while we go for control structure. Basic data types supported in R are integer, numeric, complex, and character data type. Of this, we have seen integer and numeric already. And integer, numeric, character we have seen. Then complex I have to show you now. As far as assignment operations is concerned, we have seen equal to, usage of equal to operator. There are two more methods of assignments, less than hyphen and assign variable comma value. Comments we have seen using with hash symbol. There are some predefined constants, pi, letter. This letter, a small letter, it will take lowercase alphabets, and capital LETTER means uppercase alphabets, capital A to Z. Month dot name means January to December. It will be displayed as full string. Month dot abbreviated ABB means JAN, not full word, JAN. In that short form, it will be displayed. I'll demonstrate you what are the left two things. This complex number, assignment, this one, and assign a function, and then some constants. Assign x with the value 10 and see what is the value of x. See, here is the previous execution, value of x during previous execution. Now let me execute these two statements and press Control Enter. Now x value is, whether it's integer or a numeric. Normally it will be a double value type of x will be double, and class of x is, that is a numeric. So I'm going to change this double value to integer. There is a special function associated for that. That is called as dot int. I can check the class using another function is.integer. Is.integer of x. This checks whether value held by this variable x is integer or not. So it will return a logical value. If it's true means it will return true. If it's not integer means it will return false. Now whether x is what's the type of x? It's double, right? So here the value of is that integer will be false because x is a double. Let me check. Yes, we got is that integer as x. So note it carefully. We have assigned value for x as 10. 10 is some constant. It seems like it's an integer, but actually by default R takes this value as double. So we are getting type of x as double. Then it belongs to numeric class. Now I am checking whether this x is integer. I have got the result. No, this is not integer, this is double. But I want x to be an integer. How can I get? Let me do with one more function x. Let me use another variable y as dot integer of x. As dot integer means this is explicit type conversion. That means value of x is converted to integer data type. So y will be getting as dot integer of x. Now let me display y. What we are getting? Value of y as 10. Here you can see as that integer 10L. This is the difference. X value is 10, y is 10L. You can directly give, in last example we have given this capital L, but here using function we did type conversion. Now we can check the type of y. What will be the type of y? It will be integer, because we converted x into integer data type and assigned to y. So type of x will be integer. Yes, we are getting integer value. Then class of x, class of y. Class of y will be numeric, preferably. Yeah, it belongs to integer class. Then next one is how to convert float value to integer data type. That is also possible. I can give some variable z equal 8.35. You can use assign function also. Assign of z comma 8.35. 8. Let me give some other value 9.35 and display z. Let me execute only these 4 statements. Yes, for a value of z initially we had 8.35 and we have updated the value as 9.35. So this equal to assign and less than hyphen. These 3 are the different ways for assigning values to the variables. Equal to, assign and less than hyphen operator. Okay. Right. Let me remove this this quote and check. 92 or 95 something. Whether it works or not. No. So in this function you have to give using single quote only. $95.35. This can be converted to as integer. Now I have converted this double value 95.35 into integer and stored in a new variable w. And let us check this here. See here, there is one more variable w is added whose value is 95. If 95L, if you give type of w, certainly you are going to get integer only, right? So here, this using this as dot integer function, it's possible to convert a float value to a integer, right? Similarly, many as dot functions are available. Let us check with character values. X equal to some characters. Hi. It's a string. Let's check with the numbers first. 456. So this is a string 456, but I want a number 456. Now 6. This is a string. See, you are getting the output in double quotes. So this is a string. But if I want to get a numeric value, some 456 means how can I do? Using as dot integer. See here we are having too many as functions. You can have as dot integer, as dot character, as dot numeric. Too many functions are available. You can check with every one of it. So I'll, for example, I'll give you as dot integer of x. Let us rename this destination variable y and print y. Now there is a difference. X will be holding 4, 5, 6. But y will be holding 456, which is an integer. Okay. So type of x and type of y. For clarity, I'll clear this window. Now I am executing only these two. A string is converted to integer. See the difference. 450 initially 456 is of character data type. Here you got the output in double quotes. Here there is no double quotes. This is an integer. You can see in global environment also x is a 456 string. This is updated. This value of x. This is updated value of this x 456 as a string. Then after that y will be integer. Okay. So this is with data types. Then complex I'll explain. Let us take x equal to 6 plus 5i and see what is x and what is type of x. See, this is of complex data type. Here it's changed. X equal to 6 plus 5i. Likewise, you can assign logical value or string anything to else and you can do explicit type conversion. Let me check with some whether it's possible to convert character to integer. See, here we have given 456. Where is that example? Ah, here we have given 456 as a string and converted to integer. Now let us check some string value hi, and let me try to convert to in C and other languages. It will take the, if you do explicit conversion, it will take the ASCII value of first letter. But what happens in R? We'll check. Display the value of X, then convert as dot integer of X. Y, type of Y, and here type of X. Execute only this. See the change. Here there is a warning message. N is introduced by coercion because the string hi cannot be converted to integer. It will raise some error. Okay. So that's all with data types. Let me save this file. And let me move on to next topic. So we have finished integer, numeric, complex, character, then all these assignment values, comment lines, predefined constant. I'll show you while using control structures. Already we are having keywords to be demonstrated and this predefined constants to be demonstrated. Then relational and logical operators. Less than or equal to, greater than or equal to, double equal to, not equal to. And for logical is concerned, single ampersand, double and ampersand, single or, double or, and not. There are for relational operators there is no difference. It has a usual name. And for logical operators, there is difference between single and double AND. If you go for a single AND is for combining two conditions, and double ampersand is for checking the values for series of data, like array concepts. If you are having two set of elements and want to compare those two sets, means you can go for double ampersand. In that case, if you use a single ampersand also, it can compare two set of data. But if you use double ampersand, it will compare only the first element and execution will be stopped with that. And final value will be the logical operation between first two elements instead of the entire sequence. If I demonstrate, you can understand it very well. So, let's explain the predefined constant x equal to 5 and x. We are getting x equal to 3.14. Then x equal to, let us see here, you are getting lowercase letter. Instead, x equal to letters, you will be getting uppercase letter. See, this is R is case sensitive. You can't you can't change the case of variables. Here, you have to say x instead of variables. You have to say it as an object, because by default this is not a variable. It's a vector object. I will tell you how an object is different from variable. Variable means the data type is fixed. Here, X is an object of vector data type. Vector means sequence of data, like arrays. Every variable is a vector or array of so that is the difference between variable and vector objects. In R, every variable is an object, vector object of length 1. X is assigned with capital letters, and let me display the value of X. Yes, you are getting uppercase A to Z. And there is one more function, X equal to month dot name. These are all predefined instance. Then X equal to month dot abbreviated form. See the difference? February, March is represented as full words. Here, this is in abbreviated form. So this is the difference. So let me save this file as predefined constants and go for next one, that is relational operators. For relational operators, you can use as any general purpose programming language. Let us see how this relational operators works. I will assign the value 60 for X and value 20 for Y and check the relational operator functions. X less than Y, X greater than Y, sorry, X less than or equal to Y, X greater than Y, X greater than or equal to Y, X double equal to Y, X not equal to Y. See, X is 60, Y is 20. Whether X is less than Y? No. So this is false. X is less than or equal to Y, that's also false. See, here X is greater than Y. That means 60 is greater than 20. So that is true. Greater than or equal to 20 also true. Here in the next statement, X double equal to Y. That means 60 equal to 20. It's checking whether 60 is equal to 20. No. 60 is not equal to 20. So here it's false. Here it's true. For functioning with relational operators, you can also compare strings. So any relational operator will return the value logically. I'll show you with strings. Before you can guess how the output will come. X is high, X is everyone. Oh, sorry, Y is everyone. These two are different strings. Okay. Which one is lesser? Which one is greater? You have to compare with ASCII values. E comes before H, right? Y is lesser. Let's execute and see. Hi everyone. X is less than Y? No. H is greater than E. So that is false. So automatically less than or equal to will be false. As H is greater than E, greater than Y, will be true. Greater or equal to Y will also be true. X double equal to Y is false. Similarly, you can check for floating point also. Next one is logical operators. Logical operators, we have seen single ampersand, double ampersand, single or, double or, and not. Let me take x equal to 10, y equal to 20. I can check x ampersand y. See, as far as logical operation is concerned, both positive and negative numbers will be considered as true. Both positive and negative numbers will be considered as true. But 0 is always considered as false. So if I give 10, and for clarity, I can give x equal to minus 2. Hmm? Here I am having, sorry, y equal to minus 2. I am having one positive number and one negative number. Both are true. So x ampersand y will be, what will be the output? True, and true is true. You can see true here. True and true is true. You can clear this global environment using this brush. Now you can see the values in the global environment. X equal to 10, y equal to minus 2. This brush symbol is for clearing the objects in the workspace. So negative numbers are not false, negative numbers are also true. Let me check with 0. And I can check, is that logical of x, and is dot logical of let us keep the previous one as such so that you will understand the difference. We change the variable I equal to 20, j equal to 0, and check is logical of I and is logical of j. What happens with x, I ampersand j? This is the first one we've already seen. One variable is positive value and one variable is negative value. Both are true. So when we add, you will get again a true value. And in the second case, the first variable I is positive number, second variable j is negative, 0. So this I will be true. What about j? because this is a 0, it's a false value. We can check the type here is whether it's having the logical value I and j. We can execute this. This is false because 0 is false. Instead, you can give I you can see the value of I and j and 0. The value is false because 20 is true, 0 will be getting I ampersand j. Then you can check not of 10, some 25. Or you can assign to some variable and check. Not of 25. Not of 25 is false because 25 is a positive constant. That value is true. Not of true is false. So this is with a logical operator. Let us check with whether logical value will be applicable for character data type. Definitely not. I am assigning x equal to welcome. We check not of x. So x is a string. How this not function work with string? It's an invalid argument. So character data types cannot be or strings cannot be used with logical operators. So these are the fundamental concepts with the different types of data. Let me check logical operators. I have not stored it, so I am storing now. Okay. What is the next topic? Next one is sequences. Sequences means continuously ordered numbers, like automatically creating the arrays. We can go for sequences. 1, 2, 3, 4. In that order, we can generate the values or any other sequence. There are two methods here, colon and sequence function. Colon is a symbol. Using this symbol, you can create, and using this function also, you can create. There are two types of sequences, integer and float. And another function related with this is repeat. So I'll explain all these things, how to create an integer and float sequences, and what are the different ways of creating the sequences, and how to replicate the data. Next is, suppose I want to create 1 to 10, I can create the sequence using this colon operator. Okay, so we are getting like this. I have cleared this environment as well as console so that you can see the output with clarity. And I'm executing this. It will generate the sequence 1 to 10 and you can visualize it here. Similarly, I can create a float 5.2 to 25.5. You can do 5.2 float sequence. You can create 5.5, 6.5, 7.5, and so on. This is using colon operator. Similarly, how can we use a sequence function for creating this integer x equal to sequence of starting value and ending value followed by some step value. Step value, let me give 3 and see the result. Start from 5, end with 15 and step with 3. This step is optional. If you skip it, by default it will increment by 1. If you give this, it will do 3s increment. See, 5 to 15 will be generated. 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14. So this is the use of by. You can create sequence in reverse order also. 10 to 1. I can create 10 to 1. The default value is 1. 10 to 1 with minus 1. Sorry, here if you use a sequence function, it's taking the start value and end value. So if you want to give like this, do not use sequence function. You can give as such. For example, x equal to 10 to 1. 10 to 1 and print x. Yeah. Now it's displaying value 1098, generating the sequence in reverse order. Suppose I want to give in some steps, decrement by minus 2. See here 10 minus 2 is 8. It has taken decrement by minus 1. Okay. We can generate the sequence using the keyword from and to. X equal to sequence from equal to 1, 2 equal to 5. These keywords are optional, but you can do 1 to 5. Then another way is x equal to sequence from 1 to 5. In this manner also you can create 1 to 5. There is a function associated with this called length. X equal to 1 to 5. Let us have 15 of length 5. What it means, you can have only 5 elements in this sequence. So how it will partition to have 5 elements? It will partition from must be of sequence default, from must be of length 1. X equal to sequence of 1 to, okay, I have given colon, so that is the mistake. So 1 comma 15. This is the starting number and this is the ending number. Here length is 5. So it will be split such that there are 5 elements here. Next one is replicate function. How to use replicate function? That is for repeating the elements. The syntax for replicate function is REP some element followed by number of replications. For example, if I give 4 for number of 3 times, that means 4 will be printed for 3 times. See the output here. 4 is printed for 3 times. The same replicate function can be used with sequences. Suppose I am creating a sequence 1 to 5 and replicate this sequence such that x is repeated for 3 times. I have created a sequence with 5 numbers 1, 2, 3, 4, 5 and replicate this sequence for 3 times. See 1, 2, 3, 4, 5 is replicated or repeated for 3 times. Once, second, third. Instead, if I want to, here the entire sequence is repeated for 3 times. Instead, I can repeat every element for 3 times. For that, I have to use a keyword repeat x, each equal to 3 times. So each element in x will be repeated for 3 times. You can see the difference here. Here, this entire sequence is repeated for 3 times. If I give each, every element is repeated for 3 times. One for first element for 3 times, second element for 3 times, and so on. Okay. So this is with sequences. Next, let me see control structures. The common control structures used with R are if and else and if, and there is a special control structure if else, and then normal iterative statements. Okay, what is if else if, and if else? Let us see. I am assigning x value as 10. X value as 10. If x greater than 0, print positive. This is simple if statement. Without any condition checking or follow sequential flow that we see already. Here, this is simple if statement. If x value is greater than 0, print positive. Let us see how it returns the values. Yes, the output is positive because x value is 10, which is greater than 0. It's positive. Okay. Suppose I want to use else. How can I use? Else print negative. Any else or else if any keywords must be preceded and followed by parenthesis. This is the syntax in R. Now I will execute all these statements. Let us see the output now. X value is 10, which is positive, so else part will not execute. So we are getting the result as positive. Let us change the value of x as minus 10 and see the result. Definitely, this is less than 0, so else part should work, right? You will see. Yeah. Now x value, see here, x value is minus 10, so it's returning the value negative. Okay. Again, The next one is, now we have finished if and else. The next one is else if. How can we do else if? Else if x less than 0, put negative, and if neither case holds true, print 0. If x is neither positive nor negative, it will be 0 only. X is 0. Right. Will assign the value 0. So it will check for, this is a ladder if statement. If x is greater than 0, x will be positive. If x is less than 0, it will print negative. Otherwise, it is 0. Yes, now x value is taken as 0. So it comes to default else. Now x is 0. So we have executed three types of statements. First we got x as, first we have given x equal to 10 and checked if x greater than 0, print positive. This is first one I demonstrated. Then I have given example for if and else. This is simple if, and then I am summarizing this. If and then else. If and else. In this case, I have given x is minus 10. Else print negative. When x equal to 0, if x is greater than 0, print positive, else it's less than 0. This is for ladder if. Okay, so we finished three types of if statements. Selection statements. The fourth one is the special category. This is like inline if, like a question mark operator we use in C language. Here we can use, we can write if statement in single line. If else, there is a difference between if and else. This is different, if else is different. This can be written in short form like the same code. The same code I am writing in short form. I will assign x equal to minus 20. If else, using if else I can check. Here is the condition. If x equal to 0, print as positive. Otherwise, this is true. Statement for true condition and followed by statement for false condition. If x is greater than 0, positive, here is the else part. Otherwise, print as negative. We can compare this statement with this one. We have given some value, some negative value to x. If this value is greater than 0, positive, else negative. So what will be the expected output here? Based on the value of a, the expected output will be negative. Let us execute and check. Yes, we have got the negative value. X is getting minus 20. So same if statement can be written as inline statement like this. Single line. You can write if else single line. So this is with the selection statements. I hope the time is up, so we can wind up this session with this, and remaining things we will consider if possible in subsequent webinars. Thank you for your support. I hope you had a happy learning and enjoyed the class. If you have any doubts, my email ID will be displayed in chat box. You can communicate and get. Thank you.